Hello, everyone, and welcome to our data science event for politics. My name is Julia, and I'll be your host for today. We'll have two talks today. The first one is with Ben Newey. He's a second-year PPE student with an interest in applying statistics to the discipline. We'll have a discussion of the use of data science to predict the 2019 general elections by combining multiple polls in an efficient manner. The second talk will be hosted by Tim Hargreaves. He's a maths and stats student with a focus on making data interpretable and accessible, showing how social media data can be used to predict presidential approval ratings in the US. Links to the presentations can be found in the description. So without further ado, let's start with Ben.
Thanks, Horia. Well, it's a pleasure to be here, first of all. It's certainly more interesting than most of what I'm doing today. So thank you to everyone at Warwick Data Science Society for inviting me here. So I'm going to be talking about the work I did in modeling the 2019 election in the UK and what went well and the various flaws in the model that I did. So basically, if you do have any questions, pop them in the chat. I'm keeping an eye on it, so please don't hesitate to ask, and I'll come back to them at the end. So what's the point in doing this? So there's quite a few reasons, really. So firstly, elections are they're uncertain. You know, if someone asks me what's the result of the 2024 election going to be, I would have no idea. They also really matter. I'm sure you're all looking quite closely at the 2020 presidential elections in the US. And even though that most of us aren't American citizens, it clearly matters what happens across the Atlantic in the decisions we make in everyday life. So political parties care about it, businesses care about it, we care about it just because it's interesting. And also polling's bad at predicting results for two main reasons. The first one is extrapolation errors, just because, you know, most polls poll maybe 2,000 people. And we're asking that to extrapolate that to 67 or so million people. And clearly there's going to be some errors in that. And the second reason is just because of our electoral system, the share of the votes doesn't necessarily reflect the share of the seats obtained. It's very rare for a party's vote share to perfectly map to the seat share. And also poll results diverge. In pretty much all elections, Ipsos Mori might say one thing, Survation might say another thing, YouGov might say another thing entirely, which is right. And that's sort of the question I want to answer in my analysis. So there have, of course, been lots of election models that have existed before me. There's a whole lot of research at the moment going into demographic predictors. So we're asking the sort of question, okay, what does one's education level, how does that influence your probability of voting for a given party? Is this just because you're more highly educated, or is this because you just happen to have a higher income because of your level of education, and that's what's correlated? That's what's causing the increased probability to vote a certain way. I can't tell you that for certain. There's a whole lot of research on. You can just Google it. It's really interesting. And also, what's quite in vogue at the moment are MRP models. So what this does is you poll a fairly large sample of people, and then you get an algorithm to train it to look for these demographic predictors. And then when you extrapolate that to the rest of the population, because the demographic predictors are freely available, because the ONS collects them, then it means it's a relatively inexpensive way of getting good seat predictions. So YouGov is quite fond of this, has been since 2017 or so. Electrical calculus is also another big thing that uses that. I could not use that mostly because I have no budget. So I've sort of wanted to take a step back entirely and look at the polls themselves and what drives them to be more or less accurate than how they are. So the real question here is, how do we choose a suitable metric? How do we say, okay, this poll's accurate, this one isn't? So some kind of average would work because we need to capture multiple errors. It doesn't matter if the Conservative vote share is perfect, because if that's perfect and say Labour's 10 points off, then that is still not a very good poll. But the arithmetic mean isn't going to work. Because the sum of the errors is going to be 0 a priori, and therefore the arithmetic mean's also going to be 0. So it doesn't actually tell you any useful information. So instead I define something called mean absolute error. I'm going to be referring to that a lot, so enjoy. So that's just taking it of the errors. So it just means all the errors are positive. So you do get some kind of average, but it doesn't sum to 0 by construction. So some things don't have an effect in some years. This is the 2017 general election regressing MA on the sample size of the poll. There's quite a big variation. You can see they're sort of clustered around sort of 750 and about 1250, then around 2000. And clearly it makes pretty much no difference. They all bounce around about 2 percentage points. But sometimes they do. This is 2015. And obviously it does seem from this graph to be a little bit overfitted. But you can sort of see the point that sometimes it does make a difference in some years. So how do you get around this? Well, this is a pretty big assumption that I made, but we just assume it's fairly static and just take the average. So this may have flaws over time, but in this model, I just assumed it's static. We have to have assumptions in everything we're doing, but it's definitely something I'm interested in testing in the future. So what determines polling accuracy? And that's sort of the question I was trying to find out. So I tested the following predictors and their first degree interaction. So sample size, that makes sense. If you poll more people, the poll's probably more likely to be accurate. Methodology. So is a poll taken online, conducted online, is that more or less accurate than a telephone poll or an in-person interview poll? So that's sort of the question I was trying to ask. The polling company, I'm sure lots of you have heard the chant on Twitter, "I'll wait for Survation." That does actually have some basis in reality, because Survation tends to be a pretty good polling company. And in general, some polling companies just happen to be more or less accurate than others, just because of the way they collect data, maybe the people they select. And also the date the poll was conducted, you can fairly reasonably see that if a poll the field work is taken close to the election day, it's probably going to be more accurate because there's less time for people to change their minds and all of that. So that's how it works in theory. In practice, it doesn't actually make a difference. Certainly not a significant one. So with all of these, I took polling data from 1992 to 2017, so that's 7 elections, and 224 polls in total, which is a decent number to work on. I would love to take more, but unfortunately there just aren't enough polls around. Such is the nature of the model. And that means that we get a nice linear regression function. And the R-squared is okay. The model fits the past data. It's okay. It's not fantastic. I would like it to be better. So it's likely that there's some omitted relevant variable bias that we should be aware of. And then with this, so we know the 2019 input. So even though we don't know before the election how good the poll will be, we do know who took the poll. We know how many people it polled, etc., etc. So then we can predict the MAE. And now we have a set of predicted errors, which is great. So we want to weight this now. So the more accurate a poll is, the stronger it's weighted. And you can just do that with a reciprocal function, which just means as the predicted MAE falls, we just weight the poll more strongly, which is great. So how well did the regression predict error? You can see it in this graph. The green line here is just a 45-degree line. Ideally, we want all the points to be on that line. Clearly, they're not. Because most of the points are above that line, we can see that the actual MAE was a bit bigger than predicted, which isn't ideal, but there we go. The correlation also isn't very strong, but at least it's going in the right direction. So it's not perfect, but it's okay for our purposes. So then we can just calculate a weighted average of those polls to get vote share, which is fantastic. But the big question is, how well did it work? And you can see here, it actually worked pretty well, but with a fairly big caveat in that it didn't actually perform any better than just a simple polling average where we weight every poll equally. We say, okay, everything's about as good as every other poll. So that suggests my model wasn't particularly effective in teasing out what made one poll better than another, because you can just ignore all those differences and get just as accurate a model. Even so, all the same, it works quite well, especially in Labour. That was off by 0.3 percentage points, which is ideal, really. So, of course, in a proportional system, we would be done, but that's not the case in a majoritarian system because there's imperfect mapping. So I made another big assumption, which is not necessarily accurate, but it doesn't make too much of a difference, which is that of uniform national swing. So that means that compared to 2017, we assume that all of the constituencies on a point estimate basis, they change by the same amount. Now, is that an accurate thing? No, probably not. My model would not be very good at predicting the results in individual constituencies. Is that a big problem? Also, probably not, because if I have to underperform in one seat, then it may overperform in another seat. So we can hope that there is sort of balance out. And to be honest, there's not too much we can do about that without looking at individual constituency data. And then with that, we want to run a simulation, because the point estimates were very well, but there's obviously going to be some deviation from that. So I've got a baseline just of the change, the expected change in vote share from 2019 to 2017. Apply that to every constituency. We can also assume that one party's share is going to be linearly dependent, because since all the party shares are going to add up to 100 just by construction, and then that just means if we know every party's share except one, then we know the other one just by doing 100 minus the sum of those party shares. So then we want to introduce random shocks based on how varied the polling errors are expected to be. Big question here, do we want them to be dependent or independent? By which I mean, do we want the shock in one constituency to influence the shock in another? I originally assumed they were independent, which shows that there's a massive gap. It's pretty much, these are 1,000 simulations. Labour's never going to catch up, even in the 11 days before the election. So that's all very well, but it seems a little unrealistic, because if we think of a shock as an error in a poll, So if we say that one constituency is out by a bit, then it's quite likely that the other constituencies are going to be out by about that amount as well. So then if we assume the shocks are dependent, it changes quite a lot. You can see that the point estimates are still the same, as you'd expect, but the histograms are wildly more spread out. And you can see there are a few simulations. It's unlikely, but there are a few where Labour can overtake the Conservatives there, even 3 or so where they can actually get a majority. So clearly it does make a difference, and I did use dependent shocks in the end. So like the weather, we want to forecast probabilistically, just because it's just a more helpful thing to use than to just say what the expected seats are. So I put the probability of a Conservative majority, been over 75%. Labour majority, almost never going to happen, but never say never. And plurality, a bit below 95% of the time. And that's just from the histograms. We can just compare them and overlay them. So how good was this? It was actually pretty good. So with Conservatives and Labour, I was about by about 20 seats each way. Liberal Democrats, although the actual amount was a bit lower, just by the magnitude of just relative to the size of the parties, the Liberal Democrats were a bit further off. But then if we compare to other predictive models, obviously the exit poll is going to be more accurate than me, just because the data they get is much better. It's on the day of the election, it's after people have actually voted. Electoral calculus was slightly better than me. It was certainly much better at predicting the Conservative errors, the Conservative seats and the Liberal Democrat seats. YouGov and focal data, not so much. I outperformed them a little bit. I think the key takeaway here is that with no budget, that's actually pretty good. So I'm happy with that. So why did it work? First and foremost, I don't want to take too much credit for it. Just the polls were accurate. It was a fairly easy election to call, so it makes pollsters feel very smug, but the polls just happened to be good this time around. And also the constituency errors were mitigated. If there's 650 constituencies in the UK, and then there's 1,000 simulations, doesn't matter if there's a constituency error one way, because it's definitely going to be balanced out the other way. But of course, there are a few flaws in the model. I am just coming to the end of my talk right now, so if you do have any questions, pop them in the chat. I'll do my best to answer them. So one of the flaws is that the UNS assumption didn't hold. That's not really something I could do much about, but it's a flaw nonetheless. And also the static assumption needs testing. It's possible that the model wasn't a particularly good predictor just because of the static assumptions. So I'm interested in the future in looking into that and seeing whether, say, the sample size effect gets bigger or smaller over time. And also the predicted errors tends to be a poor fit for data. That's potentially just an effect of the second point, but it's a biggie. And it happened to work out okay this time because the polls were extremely accurate. But if the polls were less so, then it's something that would cause bigger problems in the future. So what's the best way of adapting this model? So, well, it can be adapted to pretty much any majoritarian systems. The one I'm really looking at the moment is the 2020 presidential elections. Clearly, they matter quite a lot. I'm also interested in seeing whether the uniform national swing assumption holds there, because they have statewide polling, whereas constituency level polling in the UK is quite rare. So I'm interested in seeing whether state level polls are more accurate than the national polls. I'm also interested in adapting it to a dynamic model just to see if there's some trend over time of the say the effects changing, even in sign, perhaps. And it's also potentially got utility in indirect forecasting outside elections, because we can think of a poll as a signal to the eventual outcome of an event, and that's got uses in pretty much, well, in a really wide variety of uses. So, and also adapting it to constituency predictions, which is going to be challenging to do just with the level of data I have. But it's definitely something I'm interested in doing. So just now, I'm just going to ask if there are any questions that anyone wants to ask. Just pop them in the chat. I'll do my best to answer them. I'm also aware there's a little bit of a lag, but that's okay. Perfect. Yeah. Okay, so there's a few questions here, so I'm going to do my best to answer them in the little time I have. So firstly, what's your view on the Cambridge Analytica scandal? Is it ethical or not? I think it's something that's really, it's really iffy in my opinion. I don't think it's, I think to an extent you can, I think privacy is something that's really important to be discussed with data, especially since big data is becoming more and more in use around the world. So I want to look at, I think transparency is the main thing for me, because the effects that it's had on, say, the 2016 EU referendum, the presidential elections, is very unclear, and I think it's a big problem in our democracy, and I think it's really something that should be looked at. Is this a model that can be quite, yeah, just got covered. How much further do you think you could get with a bigger budget? That's a great question. I'm hoping I could get a bit further. I think if I did have a budget, then my model would probably change in quite a significant way, because I think the key thing I'd want to build in is looking at how demographic predictors affect election results, because the big problem here is that constituencies are quite heterogeneous. So, for instance, I live in the constituency Southeast Cambridgeshire. It's a massive constituency, so there's going to be quite a bit. Even if you're looking at constituency level polls, it's going to be quite difficult to look at demographic effects. So I'd be interested in taking sort of more focus polling to see exactly how certain demographic predictors work. I'm also aware that there's not too many polls, and that's a shame. I think, the more data, the better. So another question, would having constituency level polling help other polling groups enough to justify the cost? I mean, the easy answer is I don't really know, because there's just not enough data yet. So there have been some constituency level polls. Certainly in 2019, the Liberal Democrats conducted quite a lot of polls. So that's something worth looking into. I think it'll probably become more apparent in the future. I have to say, the cost of getting constituency level polling is actually quite significant, because I think it's less of an issue now than it was, say, 5-10 years ago, because I think the main reason people use online polling is less its accuracy, just because it's very cheap. You can go on YouGov, you can take a poll, you don't really have to pay them very much at all to do that. So I think it might, as online polling becomes cheaper, it'll probably become effective. I'm not sure it makes a big enough difference at the moment for it to justify the cost. And finally, what are the main flaws of the model that I outperformed? So I outperformed YouGov and vocal data. I have to say, I wouldn't say that I think outperformed is probably a big word, because you can see that the difference between my polls and their polls, it's not actually that big. It's maybe 6 or so seats. So to be honest, I think they've got perfectly good models, and I think the main flaw with using MRP models, as YouGov and Focal Data use, is just the cost. So YouGov's MRP model, they had to poll around 100,000 people. So I did originally try including it in the polling average, but when you've got most polls conducted about maybe 1,000-2,000, and you've got a negative relationship, having 100,000, that's going to completely mess up the model. So I think the only problem with that is costs, but to be honest, their models are pretty accurate, so I think it's probably justified. But then again, my model doesn't cost anything to use, so yeah, it will certainly be interesting to talk to someone there about how our models differed exactly. So with that, I think I will come to the end. Thank you again for all of you for listening to me rant at you for 20 minutes. And thank you for Warwick Data Science Society for hosting me and just putting on this talk. It's going to be really interesting. Definitely check out the other events they're doing. So without further ado, I'm going to pass over to Tim.
Okay, so thank you, Ben. So I want to start by welcoming everyone who is attending this talk, whether you're listening live or watching after the event. I want to give a big thank you to Ben for stepping in to give this talk. I certainly found it very compelling to see, how just a bit of data science can really create a model that can compete quite well with existing solutions. And I hope that people enjoyed seeing that. It's really good to see a real life application of data science to be solving a real problem. And so in a similar vein, I'm going to be looking at how we can use social media data to predict presidential approval ratings in the United States. So we'll kick this off with a bit of an introduction and a little bit about my background. So my name is Tim, and I'm Maths and Stats undergraduate student at the University of Warwick. I'm currently between my second and third year, undertaking a placement at AstraZeneca, a pharmaceutical company. And so in that role, I work as a data scientist, but I work with a lot of chemists and engineers who don't have such a strong background in computer science or statistics. And so because of that, I've learned the importance of interdisciplinary data science in helping people to use data to answer the questions they care about and let them use their domain expertise as well as possible. And now the most important thing to know about me for this talk is that my knowledge of politics is extremely mediocre. So I could probably recognise the big names in politics, but if you asked me to tell you anything about these people, I would struggle a lot. And so why is this important? Well, I hope that this talk can act as a form of inspiration to people who do have an interest in politics or are even studying the subject, to go, well, if this person who doesn't know that much about it can produce these models, these insights, and gain these understandings, well then, what could I do with my domain expertise? Because really, the toughest bit of data science is developing that experience within your own subject. The computer science and stats side of it, there are a lot of great resources available to learn them, and you can pick them up fairly easily. But developing that legacy and breadth of knowledge and to be able to apply things to solve problems, well, that's the tough bit. And so if you already have that, you're in a great position. And so I hope that this talk will act as a form of catalyst to inspire people to go, well, maybe this data science thing is something I should look into to further my career or answer the questions I want to answer. And hopefully Warwick Data Science Society can help that with talks and teaching. But Horia will mention more about that at the end of this talk. And so what is the objective for this talk? Well, what I want to do is to create a model that will predict Donald Trump's presidential approval rating retrospectively for the past 4 years in an indirect manner. So rather than using any data that directly tells us this, or maybe using news articles which would explicitly mention this, we're going to indirectly use social media data. And in particular, we're going to use the platform Reddit to try and achieve this. And more specifically, we're going to take comments that refer to Trump and analyse them to try and determine what sort of sentiment they have. Are they talking positively, negatively, or neutrally about him? Then hopefully we can use this as a form of proxy to infer what the true presidential approval rating is over time. And so why Reddit? Well, there's many different social media platforms available, but I decided to go for Reddit for a few reasons. The first being that Reddit is a very internety culture. I think that's a nice way of saying highly vocal and opinionated, that Reddit doesn't hold back with its views at all. And when we're trying to analyse sentiment to figure out how people feel about a certain person, well, then having them being very open and expressive is useful for having a strong signal. Now, on top of that, Reddit has quite a wide spectrum of views, whereas Twitter might be slightly liberal leaning. Reddit is quite neutral when you look at the community as a whole, and so that's quite good for capturing all those different views in predicting the approval. It's also quite easy to access Reddit data, and we'll be using a publicly accessible dataset, and in a similar way it's quite easy to access Twitter data. But certain social media sites such as Facebook, LinkedIn or Instagram, because of their strong privacy settings, it can be quite harder, more difficult to get access to that data. And finally, an advantage of Reddit is this notion of subreddits. So Reddit is built up of these small communities which each have some sort of shared interest. There are subreddits for politics, for Democrats, Republicans, or other things such as Marvel films or baking. So it may be interesting to look at this analysis from a per community level and figure out which ones are good at predicting approval ratings and whether there's any interesting patterns that we can pick out from individual communities. And so a little bit about the dataset I'm going to be using. The link to this can be found at the bottom. Remember, the presentations can be found in the description. It consists of 6.5 billion comments, and that spans back 15 years, going from October 2019 all the way back to the start of 2005. And in total, this amasses around 1.2 terabytes of storage. And so to put that in more tangible terms, that's about 600 HD movies. So it really is an awful lot of data to be playing with. And you'd hope that with all that data, you'd be able to draw some interesting insight. So some people might be thinking, well, with that much data, surely it's going to be really difficult to process it. Like, how are we going to do that? But it turns out that actually, with modern data science techniques, it's quite easy to handle data of this scale. And we can draw some insights with actually relatively little effort. And so the way we're going to do this is by analysing the sentiment of each of these comments to figure out whether they're positive or negative. And to do this, we'll use a technique called sentiment analysis, unsurprisingly. So I want to start with a little introduction to how this works and how we can apply it to a problem like this. So at a high level, all sentiment analysis is taking a body of text and trying to predict whether it has a positive, negative, or neutral sentiment. Now, if we want to take things a bit more complicated, we can try and determine the explicit emotion that is associated with that text, maybe anger, confusion, or joy, or some combination of these. Now, there's two ways we can try and approach this. The first is called unsupervised sentiment analysis, and this works at a per word level. We look at each word and determine what its sentiment is. So happy would have a positive sentiment, and sad would have a negative sentiment. And then we aggregate these over the whole word and average out those sentiments to get a sentiment for the whole text. So we take it from the individual words to look at the whole text. Now, the other approach is called supervised sentiment analysis. And this is almost the reverse, where we look at the text as a whole and we assign a sentiment label to that whole text. And the way we normally do this is by getting a human to label them. And so, because we have these explicit human labels, our models can be a bit more complicated, but there is that overhead of requiring those human labels. And so unsupervised learning, although not as powerful, is much simpler. And we like simple, so we're going to keep it nice and straightforward using this simple positive and negative sentiment and using unsupervised learning, working on a per word basis and building it up from there. Now, I realise that I've gone over unsupervised and supervised learning quite quickly there. If there's time at the end and people have questions, I can go into more detail on what the exact difference is and when you might use each example, but we'll leave that till the end. So we'll start with an example, and you'll see a little note at the bottom here saying that this is an oversimplification. I am lying to you a bit, like 80 to 90% of what I say is true, but it's not the whole story. But I think it's much better getting a general idea than going into the nitty gritty and getting confused. And so if you understand this, then you do have a general idea of how sentiment analysis works, and you could easily talk about it in a discussion. But do bear in mind, it's not the full picture. So we'll start with a sentence like this: I love pizza. Now, if we look at the individual words, I have given these sentiments, and I pulled these numbers out of thin air. We'll talk about how we get these numbers in a moment, but for now, I've just given them values that I think are sensible. So I is a neutral word. It doesn't really convey any sentiment at all. And so we give that a sentiment of 0. Love is a positive term, and so we give it a sentiment of plus 0.8, which is fairly positive. And pizza, it's a fairly good word, and so we give that a sentiment of plus 0.1, but it's not as positive as the word love is. And now what we can do, we can average that out over the whole text. So we add them up to 0.9 and divide by 3 to get an average sentiment of 0.3. So overall, this is a fairly positive body of text. Now another example, this film is boring. Well, we can do a similar thing. This and is don't really convey any sentiment, but film, that's a fairly positive word. Like, films are good things, so there's maybe a light positive sentiment there, but boring is quite a severe negative sentiment, and so we give that something around minus 0.7. Again, they're arbitrary numbers for now. And then when we average these out, we get an overall sentiment of minus 0.15. So overall, we would say this text is negative. Even though it has some positive words in, overall, it's generally negative. But where did these individual scores come from? Surely we have to address that. Well, what we use is something called a lexicon. And there's many of these available for free. So Bing, the search engine, have made one. And there's this open source project called Affin, which has made one. And all a lexicon is a big table matching words to their sentiment. So one example row might be the word love and the sentiment plus 0.8, or a row containing the word boring and minus 0.7. And then all we're left to do is to take our text, look at each individual word, and match it up to those entries in the lexicon, and use those for our sentiments. If we can't find our word, then oh well, we either ignore it or give it a sentiment of 0. And because these lexicons are really quite massive, unless we're dealing with very complicated vocabulary or perhaps Shakespearean English, we'll be okay, and we'll be able to pick out the general feel of the text. And the beauty of this is that all of the hard work is done for us. We don't have to question where these sentiments came from. We trust that if Bing made it, they've done a reasonable job, or perhaps you wouldn't if you know Bing too well. But the idea is that we can just trust that those will work. And so we get a lot of this for free, and all we have to do is average out over the whole text, and that gives us the result we're after. I'm sure looking at this, some people can think of places where this will go completely wrong. So rather than ignoring them completely, I want to address them and say how we would deal with that. So here's a sentence which is a bit more subtle than the previous ones. That was not fun. So here not is acting as a modifier, changing the sentiment of the word fun. And we can represent this by a multiplication. We take that sentiment of fun, which is positive 0.6, say, again, arbitrary, and we times it by minus 1 to make it negative. And so now this sentiment becomes minus 0.6. And when we average out over the whole sentence, we get a negative sentiment, as we would expect. That's generally not a positive sentence. And in a similar way, if we have a sentence like, she is incredibly talented, well, this incredibly acts as a modifier, making the word that follows it even more severe. And so what would have been maybe plus 0.6 for talented would now become plus 0.9. We have an exaggerated form of that sentiment. And now when we average things out, we get positive 0.225 as the overall sentiment. And this is higher than it would have been if we didn't have incredibly included there. So this lets us handle a few subtleties, but it's not the full picture. There are still places where this sort of technique will fall down. So an example would be sarcasm and irony. It's very difficult to handle these, and it's actually an ongoing battle in the world of natural language processing to try and figure out how we can detect and handle sarcasm and irony. So all we have to do is hope that the majority of our data set is not made up of those texts, and so they're not going to affect our model too much. But they are present and they will cause issues. Another example is non-text features such as emoticons or punctuation. Adding an exclamation mark is a form of modifier, but if we try and handle all the rules of punctuation, things get very complicated, and we're keeping things simple here, so we'll forget about that. So again, we'll have to go, well, the majority of our text isn't going to have weird punctuation emoticons, so we'll just forget about it and hope it's not too much of an issue. And actually, if you want to give this sort of thing a go for yourself, there's this link here, which again, you can find the link to this presentation in the description, to have a go with the Affin lexicon. You can type in a sentence and it will guess whether that was positive or negative in sentiment. And it's quite easy to fool this. You don't have to think hard to be able to come up with a sentence that it gets wrong, but it does a decent job. And if we remember that people on Reddit are commenting to try and share their opinion and not necessarily to trick a sentiment analysis algorithm, then generally we'll be able to pick these up fairly well. And so we'll carry on with an approach like this. So now we can have a look at the actual data that we're dealing with and see exactly how we can handle that. So looking at the data here, I picked out a few columns that are most of interest. And there's actually quite a few more, but we'll keep to the main ones. So we have the body of the text, which is literally the text that makes the comment up. We have the author who wrote it, that's their username, and the date that it was created, the date it was published on Reddit. We then have this notion of score. So Reddit has these upvotes and downvotes that you can apply to comments. If you like a comment, you upvote it. If you downvote it, then it's because you didn't like it. And so you can then take the difference of these to figure out what the overall score of that comment is. Now, related to that is this notion of controversiality. And so if a comment has a lot of upvotes and a lot of downvotes, then it can be considered to be controversial. And maybe this could be a useful predictor in figuring out which comments are best for predicting approval rating. We also have this notion of gilding, which is where if you think a comment is really good, you can give Reddit a bit of money, and then you can give a comment what's called Reddit gold, which is a way of saying, I really like this comment. And so any comment that has gold, it clearly resonated well with somebody. And so maybe that could be another useful predictor. And finally, we have the subreddit that the comment was contained in. So we could split up by these subreddits and do an analysis for each one of them to try and get a comparison between them and see how they behave differently. And so now I've got to share a random sample of some of these comments. I say random, it was random, but there's a bit of vulgarity, so I had to edit it slightly, but that's just the internet for you. And so we're left with 3 comments from politics, the subreddit politics, 3 from Democrats, and 3 from Republicans. And so that's an example of what sort of things we might have. So from that, we can generate some initial insights. Well, the first thing to notice is that the signal is quite weak, that it's there's definitely something there. We can pick out a general sentiment, but it's not easy to do. People don't speak in a very clear way. I think this is good. I think this is bad. It's more subtle. But hopefully with the number of comments we have available, we'll be able to deal with that and make up for that small signal. There's also a definite negative skew, apart from, I guess, in the Republican subreddit. But really this doesn't matter, because all we're interested in is how the approval rating is changing over time. We can scale it to make sure it matches an appropriate approval rating. So even if Reddit started generally negative, a reduction in that negativity we could consider to be more positive. And so we can actually not worry about that at all. It'll sort itself out. Sarcasm, that's going to be an issue and something we can't deal with, but we have to accept. And lastly, there's this hyperbole, exaggerating, that people on the internet tend to be quite expressive with what they're saying. And so that's something we need to be aware of going in. I've noticed that there is a question here, which I'll just address now. So since the word with zero, there's certain words that have zero sentiment are just there for sentence structure and perhaps not necessary to convey emotion, why they added into the average. So there's different methods of sentiment analysis. In some cases you might include them, in some cases you might not. The reason is to try and have a sense of how strong your signal is. You might have a sentence where you go, oh, that was really, 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 really good. And therefore all of those reallys make up more of the sentence. But if you filled that with a load of extra fluff, then you could almost say that the signal of that wasn't as strong. But as I said, like, the real picture is a lot more subtle than how I described it. You are correct in picking that out. But yeah, there are ways of handling that. So going on to actually building the model now. How did I approach this? Well, I took all the comments going from October 2019 all the way back to January 2017, which is when, well, just after Trump was inaugurated. And I split them into individual months. I then calculated the average sentiment for all short comments that contained the word Trump. And so the reason I kept with short comments was similar to what we just mentioned there, is trying to keep the signal strong. That if there's a comment which has 1,000 words in it and only mentions Trump a few times, it might be difficult to pick out which parts of, or which sentiment in that is referring to Trump explicitly rather than somebody else. And so by using these short ones, specifically less than 100 characters, we get a stronger signal. And because our data set is quite large, we don't have to worry about losing comments because of that. And then the final step, once we have this average sentiment per month, we scale it so it's on the same range as an approval rating, and then we can compare it with the true one to see how well we did. And the result of that is as follows. So this is for the subreddit Politics, which is the largest political subreddit on Reddit. The green line is the true approval rating, so what the actual poll said, and the orange is the one that we predicted from using Reddit comments and sentiment analysis. So I'll just bring up the laser pointer here to point out a few things. So the first observation is that generally the shape is fairly the same, but not perfect. So at the start, they both decrease, the actual approval rating decreasing a bit faster. My explanation for this would be that it's likely that Reddit started with a quite negative view of Trump, and so it's hard to have a sharp drop when you're already fairly negative. We then see there's these spikes here. I'm not sure exactly what they refer to, but maybe if you look at the timeline of the Trump presidency, you could figure out what those related to. And those were lined up quite well. There's an increase towards the end, and then a drop towards the end of 2010. And so a few insights there. So we have the Pearson's R, which is a measure of correlation, how well one thing predicts another. And so this ranges between -1 and 1. -1 being a perfect negative correlation, 1 being a perfect positive correlation, and 0 being no correlation. So a Pearson's R of about 0.378 is a reasonable correlation. It's not perfect, but there's definitely something there. And perhaps with some work, that could be increased. So some insights we can draw from this is that Reddit likes to overreact, which is perhaps unsurprising for the internet being the internet. If we look at these troughs here, the dip is a lot more severe in the predicted sentiment data than it is on the actual ground truth. And we can also see here that there's this massive drop here around the indictment of Trump and the firing of James Comey, which Reddit reacted to very severely. And we can also perhaps see that ignoring the start, which we can explain away with Reddit having a negative sentiment to start off with, the true polling seems to lag a bit behind the sentiment, which could suggest that it takes time for public opinion to be developed, whereas the internet just kind of runs with it without even questioning, which sounds about right. But perhaps people have other explanations of this. I'd be interested to hear. And so on reflection, looking at this model, the correlation is weak, but it's definitely there. There could be improvements made to it, but as a starting point, we've picked up on some pattern, and that's good. And one thing to note is that this metric of correlation is perhaps not the best, because we had this problem here where really these two troughs and crests here are quite well lined up. They only differ by an absolute amount, so they're detecting the same pattern, but just at an offset. And Pearson's R is not really calibrated for capturing that sort of pattern. And so really this is perhaps a pessimistic view of how well the model's actually performing. And with a better metric, we could see something more optimistic. And so looking at the model as a whole, it does an adequate job, but it is lacking subtlety. It doesn't handle sarcasm, doesn't handle hyperbole or any punctuation, and so that might be causing it to not work perfectly. We also don't include any weighting of comments. We don't use the score or whether they're controversial to try and influence that. And so I also tried to apply this model to some smaller subreddits, such as the Republican or the Democratic subreddit. And the results weren't as strong. And the reason for this is that actually the dataset gets quite small when you get down to those smaller subreddits. And you'd think, well, with 7.5 billion comments, surely we should have a lot left over even when we're on those smaller subreddits. But the problem is that most people, when they're commenting, are either responding to an article or post or someone else's comment, in which case you're more likely to refer to Trump as he or him than by his actual name. And so because of that, a lot of the data goes missing. And there would be ways to try and to factor this in and try and figure out who he and him are, but it gets quite complicated. I wanted to keep things simple. And so this leaves us with a lot of space to explore still. There's a lot more we could add to this model. We could make things a bit more complicated in terms of sentiment analysis, look at explicit emotions rather than just positive and negative. We'd also combine more data sources together, maybe bring in the news or bring in Twitter data or Wikipedia edits and try and combine them to get a bigger picture. We could also try weighting comments, so whether they have a high score or a controversial, maybe we want to factor that into our decisions. And finally, we could clean the data more, pre-process it, get it in a better state, and that could improve things. And so when I finished building this model, I thought, well, is this really good enough to share? It does an okay job, but it's not perfect. And then I thought, well, that's not the point of this talk. It's not about having the best model that's completely complicated, but rather about having something that, with a bit of practice of data science, you could go away and make for yourself. And so that's why I decided to keep it as it was, as a flawed model, but still quite simple. And the exact simplicity, well, the whole source code of this project, the setup, the visualization, the sentiment analysis, all those different features, those were all done in less than 100 single lines of code, which is barely even a page of A4. And so this really showcases how powerful data science can be in answering these sorts of questions. So I wrote this in a few hours over the weekend, and it runs processing that 600 movies worth of data in less than 30 minutes. So it really is quite impressive how it does that. So this is my final slide now, and because there is a bit of a delay in the stream, if you have any questions, pop them in the chat now. We probably have time for one or two questions depending on how quick they are. But I wanted to leave you with this interesting pattern which I came across, which was from sentiment analysis on the Republican subreddit. And as I mentioned, because the dataset size is a lot smaller for these subreddits, it's much more difficult to pick out these correlations. And so our Pearson's R here is basically 0. But it's not exactly 0. And if it's going in any direction, it's tending in a negative direction. And so that's very interesting. And what this is saying is that when the actual approval rating of Trump decreases, well, then people in the subreddit, Republicans, are actually talking more positively about him at the same time. And so it's almost as if that Republicans are defending Trump whenever he gets into trouble, which is an interesting idea. Perhaps there are other explanations of this. I thought it was quite interesting to see that something like that going on. And we can see this here where there was dips in Trump's approval rating, in the actual true approval rating, whereas the sentiment in the subreddit were having these massive high spikes. And so an interesting pattern to detect there. So now I'll have a look at some questions, if I can answer any. But yeah, thank you for listening to this talk, and I really hope you enjoyed it. And hopefully it'll convince some people to go, well, maybe this data science thing is a useful thing to consider, and you might want to have a look at it. So we have a comment here which is, do you think the results would yield a stronger or weaker correlation with the ground truth if you use this model on Twitter rather than Reddit? I think it would be fairly similar. So I think, yeah, the advantages of Reddit that I mentioned of it just being quite neutral in its views and having all these communities is very useful. But Twitter might have the advantage of there being more data. The thing I would worry about Twitter is that things get shut down a bit quicker, that it's hard to have that full spread of views. Whereas Reddit, it's kind of a bit of a free-for-all, the Wild West, anything goes. And so really, I think the best thing to do would be combine these together. Perhaps some weighting of them would be very useful. And perhaps you could look at whenever Twitter and Reddit differed in their opinion, well, that might be quite useful in predicting what's going on in the real world. Perhaps there's something very controversial which could be shown by a dip in his approval rating. I'm wary of time, so I will end my talk soon. If there's any other questions, I'll try to answer them in the comments directly. But now I'm going to pass over to Horia, who has some exciting announcements about the future of Warwick Data Science Society. So thank you for listening, and I'll pass back over now.
Thank you, team. Before we wrap up, I would like to make some announcements. Warwick Data Science is growing, and we're looking for new members, new opportunities. So make sure to follow all of our social media to keep updated with events, research, and news. We also have a research blog at research.warwickdatascience.com if people want to learn more about what we do. We also have some exciting news for the summer. We're currently planning a coding summer bootcamp for complete beginners. So if people are interested in data science but don't know where to start or don't have experience with programming, they should keep an eye out for this event. Thank you so much for watching, and I wish you all a great day and all the best.